Right, in this video, we're going to be answering the question, why does the pith ball repel when it makes contact with that vinylite strip? And remember, before, it was actually being attracted to it. So then all of a sudden it gets repelled. So what happened here? Well, without going into detail, we could ask the question, well, why would anything repel when we're dealing with electric charges? And we know that like charges repel. So I know by the very end that these two objects would have to have the same charge in order for them to repel. All right, so let's see what happened here. Okay, well, in my beginning situation, I have my pith ball, which is a conductor, and my vinylite strip, which is an insulator. And what we had done before is we had charged my vinylite strip, right? Electrons from the paper jumped over to the vinylite. So this side of my vinylite strip is negative, but this side is neutral. And the reason why is because it's an insulator. Right? I'm showing that because the atoms that make up my insulating material have a almost completely filled valence electron shell. And so since there's not a whole lot of empty spaces, these electrons, even though they may want to move over here, really can't. Right? And my conductor in the very beginning is neutral everywhere. Same amount of electrons to protons. Okay. Well, because I have this difference in charge right here, that's why my pith ball was originally attracted to my vinylite strip, all right? And now they're going to make contact, just like we saw, right? When this happens, because I have a conductor and not two insulators anymore, as long as you have one conductor, you could have charging by contact. You don't need friction as long as they make contact. So when this happens, electrons are going to jump over to where there's less electrons, right? Nature wants to be chill. The electrons want to even out. So electrons are going to jump over to my conductor in this case. Now, all my extra electrons aren't going to jump over because then there would be more electrons on this side. They're going to just jump over until they even out. So here I have two extra electrons here, two electrons here. They even out. All right, so now let's look at the charge of my objects, okay? Remember, this is an insulator, and so right here is going to be neutral on this side, and it looks like I still have an extra amount of electrons, so this side of my vinylite strip is going to be negative. Now, what about my conductor? Well, since it is a conductor and I have all these free spaces that aren't filled by electrons, not only can the electrons be on this side, so this side is going to be negative, but these electrons could also move very freely to any other side of my object. So electrons are going to disperse evenly through this, so every side of my object is going to be negative. So I could say the total charge of my pith ball is going to be negative in this case. All right. Now, I have a negatively charged side of my vinylite strip. My whole pith ball is negative. Like charges repel, so once they charge by contact, I have two negative objects, and they're going to repel one another.